Hello class, today we're going to look at section 2.7, absolute value equations and inequalities. So we have a little warm-up problem here from 2.6. Go ahead and pause me and answer the question, and then email me your response so I know that you've taken a look at the video, and then we'll continue on with the rest of the lesson. Alright, welcome back. So we're going to look at a little review of 2.6. So let's read through what we have. So we're dealing with monthly expenses for two offices are shown in the table. It's actually below, not to the right. Which of the three expenses are in a set of expenses that are greater than $2,000 for the Chicago office and less than $2,600 for the Tokyo office? Okay, so greater than. So we have expenses greater than $2,700 for Chicago. So let's look at Chicago, and we're looking for greater than $2,700. Well, rent's only $2,249, insurance $113, and housekeeping $398. None of those are greater than $2,700. So let's look at our other option, which is less than $2,600 for the Tokyo office. Well, 9,182 is not less than 2,600. 160, 374, those are both less than. Now we need to figure out what type of statement we're working with. Well, we're working with an AND statement. So that means that it has to satisfy both. So the first one, we didn't find any expenses that were greater than $2,700. So there was nothing in our first set. In our second set, we did find two. Since we're dealing with an AND statement, it has to be in both. So we don't have anything that's in both. So this would be C. So let's move on with 2.7 and look at some absolute value. So what we're going to work with is solving absolute value equations and absolute value inequalities. So the first one we're going to look at is equations. Now remember, when we're talking about the absolute value of a number, we're talking about its distance from 0. So if you look at this first example, and remember, you can pause me so you can write down definitions, stuff like that. So in our first example, we're dealing with the absolute value is equal to 4. The absolute value of x is equal to 4. So we know that there are two solutions that are a distance of 4 units away. One of those solutions is -4. It's 4 units away from 0. The other solution is +4. It's also 4 units away. So when we're dealing with absolute value, we're going to run into two solutions a lot of the times. Okay, so let's go ahead and look at the math definition of solving an absolute value equation. Again, remember to pause me if you need a little time to write this down before we go on. So what we're looking at is we have a generic equation where the absolute value of the left side is equal to a number. So it's saying, when is this value going to be a distance of k away? So what we're dealing with is we're going to take that inside of the absolute value, set it equal to the positive value k, and then we're going to also look at the OR statement. So another solution is we're going to take that inside value and we're going to equal to -k, because we know the absolute value of k and the absolute value of -k would get us the same distance. It has the same value. So we're going to solve for both of those. So let me show you how this is going to work. An example. So we're going to look at solving the equation. This is from section 2.7. This is number 15. We have the absolute value of 2x plus 5 equals 14. So we want to know when this is going to be a distance of 14 away. So we know that when 2x plus 5 is equal to a positive 14, it will be 14 units away. Okay, so when this inside portion is equal to 14, the absolute value of 14 is 14. We also know that we could have when the inside portion is equal to a negative 14. Okay, the absolute value of negative 14 is also 14. So these are going to be our two solutions. Once you get it broken apart, you understand that it's going to be an OR statement. We're just working through the steps. So on the first one, I'm going to subtract 5. And I get 2x is equal to 9. And then we're going to divide by 2. And we have x is equal to 9 over 2 as one of our solutions. Or our other solution is when we solve the right side. So subtract the 5. And we have 2x equals negative 19. Divide by 2. And we have a solution of x equals negative 19 over 2. So since this is an OR statement, we identify that both of these can be solutions. So when we write this as a solution, we have negative 19 over 2, comma 9 over 2. That's our set of solutions because it's an OR statement. So it can be this one or that one. And notice that I wrote it in numerical order. So we started with the smallest one and we'll work our way up. Let's go ahead and try another one. Remember, you can always pause me if you'd like. Okay, so in our second example, we're working with number 69, same section. It's a little different. Let's see if you can figure out what the difference is, and as you're copying it down, and then come back and we'll talk about what the difference is. Okay. What you should notice is when we're working with absolute values, we want to isolate them. So right now there's a plus 1 on this side. Before I do anything, I need to move this 1 over. Notice that it's not inside the absolute value. So that gives me the absolute value of x plus 4 is equal to 1. Now I can go ahead and break this into the two equations. And remember, it's going to be an OR statement. So if you have a value on the outside, you need to move that over. Isolate that absolute value first. So our two equations we're going to have is x plus 4 is equal to 1. Absolute value of 1 is 1. But we can also have x plus 4 is equal to negative 1. Because the absolute value of negative 1 is 1. All we have to do is solve. So subtract the 4 over. And we have x equals negative 3. On our second one, we're going to subtract 4 over. And we have x equals negative 5. Now again, this is dealing with an OR statement. So we actually have two solutions we're working here, this one or that one. So when I write my set, I have negative 5, comma, negative 3. Notice that, again, I wrote it with the smallest number first to work my way up. So that's the first type of problem we're going to work with in 2.7, which is dealing with absolute value equations. You want to go ahead and break it into two equations once you have the absolute value isolated. And remember that we're going to have the positive and negative value to solve for. Okay. Let's go ahead and look at our second type. Okay, so again, remember you can always pause to get caught up if you wanted to copy this down. Okay, so we're going to start looking at absolute value inequalities. So the first one we look at here is we're talking about the absolute value of x is greater than 4. We want to know when the absolute value of a number is greater than 4. Now remember, absolute value is talking about the distance. So we want to know what numbers have a distance that is further from 0 than 4. Okay, so we have two situations that are happening here. We know that to the right of 4, 5, 6, 7, those are all further. Those are all greater than 4. But remember, we're also dealing with the absolute value. So that means everything left of negative 4 is also going to be considered greater than 4 because we're talking about the absolute value. The absolute value of 5 is greater than 4. Absolute value of 6 is greater than 4. So again, we end up with two types of solutions. Notice the word or again. So our solutions are either x is less than negative 4, or our solution is x is greater than 4. Okay, so let's see what this looks like in a math definition. So we have the absolute value now is greater than, and this also works for greater than or equal to. Okay, so what we're going to work with is we want the values inside the absolute value to be greater than k. So it's just the same inequality, just without the absolute values. Or we can have the stuff on the inside of the absolute value is left or less than the negative value of that answer. So we're dealing with both sides. We want to know what's going on to the left and what's going on to the right of our number that we have. In this case, we're calling it k. In our original, we're calling it 4. And notice that since we're dealing with an or statement, we have that union symbol. So let's look at an example of this. So we're going to solve the inequality and graph the solution. So now we're going to put it onto a number line. So you want to identify, when you look at this, is the absolute value isolated? Yes. What symbol do we have? Well, we have the absolute value is greater than or equal to 20. So it's telling me greater than or equal to. So I'm going to have two statements. One where we have r plus 5 is greater than or equal to 20. Or we're going to have the stuff on the inside, r plus 5. But now we're going to worry about less than or equal to negative 20. So notice that I want to know what's going on to the right of 20 and what's going on to the left of negative 20. We're going to have two areas that will satisfy a distance further from 0 than 20. Right of 20 and left of negative 20. We solve, so subtract 5. And we have r is greater than or equal to 15. On our second one, we subtract 5. And we have r as less than or equal to negative 25. Again, this is an or statement. So I'm going to graph this on my number line here. Okay. So I have 0. I'm going to go up by 5s. And then we'll go the direction in the negative. Okay. So our first one is we're dealing with r is greater than or equal to 15. So we go to 15, and we're dealing with greater than or equal to, which is to the right. In our second one, we're dealing with r is less than or equal to negative 25. We'll go to negative 25, less than or equal to is to the left. So this is the graph of the solution set. We want both of them because we're dealing with an or statement. So it can either be less than or equal to negative 25 or greater than or equal to 15. If we were to write this into interval notation, well, remember this goes to negative infinity, comes back to negative 25. We have our bracket. Since it's an or statement, we have a union symbol. Starts back up at 15 and goes to infinity. So this one is just asking for the graph. So that would be on our number line down here. But if you wanted interval notation, we just created that here. That was supposed to be a star. There we go. Let's look at one more of these. So go ahead and pause me. Give this one a try. And then once you get done, unpause and compare your answers. Okay. Welcome back. Hopefully you actually paused me and you're trying, because that's how you're going to learn these concepts, is working through them yourself and then checking your answers. So let's see what we have. Well, the first thing we want to do is our absolute value isolated? No, we have this plus 3 over here. So I'm going to subtract the 3 first. And that gives me the absolute value of 2x plus 1 is greater than 5. Okay. So now we have it isolated. We're going to break it up into the two inequalities. We're talking about greater than 5. So we have 2x plus 1 is greater than 5. That's one of our options. Or we can have the stuff on the inside, 2x plus 1 can be less than negative 5, because remember we're taking the absolute value. So anything less than is okay. It's still a distance further than 5. And go ahead and solve. Subtract 1. And we have 2x is greater than 4. And divide by 2. And we have x, make sure we have the right color, x is greater than 2. Or, our other option for a solution is when we solve the right side. And again, we're going to subtract 1. This time we have 2x is less than negative 6. And then divide by 2. So we have x is less than negative 3. Okay. Our directions are to graph this. So let's go ahead and get a number line again. And let's graph the first one. So we have x is greater than 2. So we have 0, 1, 2. Greater than 2, well, we should be using a parentheses this time. And greater than is to the right. X is less than negative 3. 1, 2, negative 3. The less than is to the left, and we're using a parentheses. Again, since this is an or statement, we're going to include both of these answers. So our solution would be the graph of both of them together. Okay, it can be one or the other. If we decided to write this in interval notation, again, this goes to negative infinity, comes back to negative 3. We have a parentheses. We use the U for union for the OR statement. Starts back at 2 and continues on to infinity. That would be considered interval notation. Okay, so that's going to be part 1 of 2.7. I'm going to break it up into 2 videos. Part 2, we'll go through a couple more inequalities and some more equations. So please check out part 2.